Given the function h of x is equal to 3x squared minus x, find the ordered pair xy equals 3 for the x position and h of 3 for the y position. What's h of 3? It is the y partner to x equals 3 in the function h that's given to us. Okay, let's do this. This is easy. H of 3 is equal to 3 times parentheses squared minus parentheses. Now plug in the 3 in the parentheses because they're taking the place of x. We get 3 times 9 minus 3, which is 27, minus 3, which is 24. Thus, the ordered pair xy equals 3 comma h of 3 is equal to 3 comma 24, and it is an element of the function h of x. Okay, so that's what it means to find h of 3. You're finding the y partner to x equal 3. What if you're given g of x equals 4x minus 2, and you're asked to find g of x minus 5? Okay, it doesn't matter what they put in the parenthesis, I can find it. G of x minus 5. Well, I just remove the x's and put parentheses for the g, and there's only one place to remove the x, and insert in that parenthesis the x minus 5. Now let's simplify the equation. We get 4x minus 20 minus 2 equals 4x minus 22. Thus, the ordered pair xy equals x minus 5 for the first position, and y equals 4x minus 22. All right, so that's g of x minus 5 in the y position. Yeah, that's probably not a good way to write it. I just want to say that writing the xy, I would probably not say thus xy equals this. I would just say thus we have the ordered pair x minus 4 comma and 4x minus 22. In other words, when the first coordinate is equal to x minus 5, then the second coordinate is equal to 4x minus 22. Okay, now what if we're given the equation, the function f of x equals x squared plus 2x, and we're asked to find part A, f of negative x, and part B, the difference quotient, that's f of parenthesis a plus h minus f of a over h. Okay, I didn't finish writing that. I'll have to come back and finish writing that in a moment. First, let's do f of negative x. It's parenthesis squared plus 2 times parenthesis, because that's the definition of f. Plug in the negative x in the parentheses and simplify. We got x squared minus 2x. Now for part B, we have the quotient function. And I didn't finish writing it over there. I'll go back and do that. Minus f of a over h. Okay, so that is equal to f of a plus h minus f of a over h. Now, in the first bracket, I'm going to write the f of a plus h, parenthesis, squared plus 2 parentheses, and plug a plus h inside the parenthesis. Close your bracket and subtract f of a. That's parenthesis a squared plus 2 times a. So do you see so far how I'm using the definition of the f function, which was given to us to be f of x equals x squared plus 2x, taking the x out, replacing with parentheses, and plugging in whatever they tell me to plug in the parenthesis. In this case, it's a plus h, and the second part is just a. And don't forget the denominator. This is all over h. Now it's just algebra simplifying. To simplify the top, a plus h squared is the binomial a plus h times itself, plus we have 2 times a plus 2 times h minus bracket a squared plus 2a all over h. Okay, so let's FOIL a plus h times a plus h. We get a squared plus the product of the outers and the product of the inners gives us 2ah plus the last times last is h squared. Bring down the 2a, bring down the 2, the positive 2a and positive 2, close your bracket, and then get rid of the brackets on the second part by distributing the negative sign. You see, distribute negative sign to all the terms inside the bracket, all over h. Okay, cleaning up, we see we have a cancellation of the a squareds, a cancellation of the 2a's, and that leaves 2ah plus h squared plus 2h, and that's over h, and it's equal to, we can factor out a common factor of h, it leaves parenthesis 2a plus h plus 2 over h, and then we can cancel a common factor of h on the top and bottom, and our final answer is 2a plus h plus 2. So we did a lot of cleaning up when we applied the algebra.